variable acceleration with vectors in 2 dimensions. Example 4. To prove that two particles collide using vectors, their position vectors for both particles must be exactly the same for some given time t. So the x components of the vectors should be the same, and the y components should be the same for a given time t. So both particles are at the same point in space. Hence they collide. So here's particle 1, and we're given its position vector. And you can see it's a function of time. We're not given the position vector for particle 2, but we can work it out though. Its initial position, 2i meters at t equals 0. We're given its velocity, and we can see it's not a function of time, so it's a constant, which means acceleration for particle 2 is 0. We can use this formula for the position vector of a particle at any given time, which is equal to its initial position for t equals 0, there it is, 2i, that goes in here, plus a displacement s from that initial position. And for constant velocity, we use s equals vt, and we've got the vector form here, and v we're given ai plus 4j, so we need to substitute vt into here and then put in our initial position vector and the velocity vector into this to get this. And then we group the I and j components together like so. So when the particles collide, their x components and their y components, or their I and j components, will be the same. So these terms in yellow form an equation, they're equal to each other, and these terms highlighted in green, they form an equation, and we solve those. So x components equated, y components equated. That's a simple equation. I'm going to solve this to get t equals 4. We substitute t equals 4 into this equation. If this equation balances, that means both particles are at the same point in space for a given time. So substitute the values into here, t equals 4. The equation balances, which means the particles do collide. For practice, try these questions.